Hello, guys. There are 50 people online. That's really good and exciting for us. And we have here with us Abhimanyu Gupta. And let's like he has told me to make it really not very formal. Like I will not tell that he's a instructor of data science at Chaifetz School of Business. I will rather tell us how we met. Okay, and the idea like how we met over LinkedIn about how we really like each other's work, and then we talked about he really told me that how he really want to uh, give back to the student community, like his knowledge and stuff, and which is really exciting. And I'm not going to share spoilers to you. So and then I invited him over to this lecture, to webinar to give to the people, and he like agreed in one moment. Okay, so it's like thank you, Abhimanyu Gupta, for this coming to this beautiful event. And we have a lot of people over here who are really waiting for your beautiful ideas. The headline is really catchy, so let's get started. And I will not give any spoilers, although I'm really wanting to. So without further ado, let's get started. Okay, so the screen is Abhimanyu Gupta's. Thank you for accepting this stuff.
Thank you so much for this opportunity, Srijit, and it's a privilege and honor to me to be here to talk about that. Before I share my screen, I want to say a few words. Like I teach in a business school, and when I connected with Srijit, the thing that I like the most is how our perspectives are a little different, but we can join forces to make something bigger than ourselves. So that was the whole idea. So thank you, Srijit, for this opportunity, and
My
I look
pleasure.
forward.
Yeah.
I'm going to share my screen.
Yes.
Can you see my screen?
Perfectly. Perfectly.
Okay, give me 1 second.
Sure. No worries.
I think I can go with this. Okay, so Srijit, let me know when I need to start. Should I wait for a few more seconds for others to join,
Yeah.
or
So you can wait for a few more seconds to hit the audience 200.
okay?
But yeah, I think you should start. Okay, the 93 people over here are really waiting for your beautiful idea.
Great. So thank you everyone for joining and listening to me. So let's see how it goes. As you already know, our topic is how decision tree helps improve data visualization. So the background of the idea is this: we always create visualizations when we start working with data. In almost all the cases, creating visualizations is the first step. We explore the data, we see what is going on, we try to understand the stories and patterns that are part of the data. In my experience, what I have found is that when we take a few steps forward and then take a few steps backward, it really helps making our visualizations better. So by steps forward and backward, what I mean is if I go into the area of machine learning and use some of the machine learning concepts back in the data visualizations, that really helps. Although the machine learning is supposed to be the next step, but we are actually going backward because we are trying to, um, use some of those machine learning concepts in actually creating visualizations and telling a better story out of it. So I'll start with some examples of good visualizations and bad visualizations. And for that, I am going to refer back to the book, this particular book. Uh, and the author, she was a data analyst in Google. And this book is kind of popular book. And in our university, we use this book as a textbook as well. So I'm going to refer to this book, and I have extracted some of the visualizations. So let's say this is a visualization. The background is that this is the number of tickets received and processed. And we have plotted the, the number of tickets received and processed corresponding to each of the months in a year. So this is the ticket trend. If you look at this carefully, not much story is coming out of it. It's a good information, but not much story is coming out of it. With a little bit of modification, a little bit of tweak, we can actually make the story much more visible. So if this was the visualization before, maybe this is the one after. So let me explain what is happening. By changing the chart type from bar to line, it was very evident that the two lines are diverging from each other. And the reason they are diverging, the reason that the number of processed is becoming lesser and lesser than the number of received, is because there were two employees who quit in May, and that's why there's been a problem for the team to catch up with the number of tickets for the service requests, right? So the story is this, that the two employees quit. So since then, it's been a problem because we are not able to catch up. So what is that? So if that is the story, then what is the action? The action is this: maybe we need to have replacements of these two people so that we can catch up, right? So this is the story. So you see, from here to here, when we transitioned, we are basically talking more in terms of the reality, more in terms of the practicality and the stories and the actions. What needs to be done to, what is the problem, what is the story, what is the emotion attached to it, and how we can fix it. So the entire story is coming up pretty easily and pretty clearly in this visualization. There is another example I want to show you. This is the background of this is that there was a program for awareness. Srijit, can you hear me still?
Yeah, I can hear you properly. Yeah.
Okay, I just wanted to make sure. Thank you. So there was an awareness program on STEM or science, and this is the distribution of who are excited, who are not excited, who are bored, who are kind of interested. And the same people were surveyed after the awareness program about science. And this is the um, distribution of people now who are excited and who are not. So now, if you look at these two, basically, we need to compare to understand the effectiveness of that awareness program. And the only way to do that is basically to compare the two pie charts, which is a little difficult because sometimes I have a whole theory about why pie chart is not good, but I'm not going to talk about that here so that I can stick to the topic. But with a little bit of tweaking, it, this was created. So for each of them, now since the idea was to compare, they were put side by side using a bar chart. So you see how the excited proportion increased from 19% to 38%, and then how the okay proportion decreased from 40% to 14%. So this is the before and this is the after. So, and there is a note on the source of the data and those things as well. So you can clearly see how the same data can be represented in a little different way so that the story comes out pretty easily. And these are needed because many a times in business we base various data visualizations um, as our foundation, as our basis for the decision making. So with those two examples, I want to talk about what makes a visualization good. What are the various characteristics of good visualization? I see a comment. I want to answer that. How Shikhar is asking, how can we learn data visualization? So there are various ways, various books. I have my own course too, and there are various other courses that I can refer you to. But this is a kind of whole different topic. Visualization is a whole different topic. I'll help you with that. If you're interested, just contact me and I'll help you with it. Okay?
Hello, hello.
Hi.
Yeah, so one suggestion is that, like, students are telling me, is that can you just zoom, like, can you open a slideshow format on?
Oh,
uh,
okay, sure.
yeah, yeah, because it will look bigger.
This is better.
Yeah, this is much better.
Okay, great. Sorry about that.
Yeah.
Okay, so moving on. So what makes a visualization good? What are the characteristics of a good visualization? And I found this really interesting diagram to explain that. There are 4 different dimensions of a good visualization. The first one is definitely information, the data. The second one is story. What is the story that is coming out of it? And by story, I always mean emotions. Can can we connect our emotions with what we see there? The third one is the goal, the point, what exactly we are trying to prove. And then the fourth is a visual form, in which form I am presenting the data. So if you go back to the first example, basically from here to here, um, it's very clear that there is information. For example, the numbers 156, 202, and so on. There is a story. The story is clearly here. There is a goal. There's obviously a goal. The goal is to convince the management that we need to hire 2 more people as replacements of the people who quit in May. That is the goal, right? And The fourth one is a visual form. So we selected this visual form, the line chart versus the bar chart, because that supports the storytelling more. I see a question, how I can contact you. So you can always contact me via email. Srijit, is it possible to publish my email
Yeah, I have sent your
somewhere?
LinkedIn profile to them.
Okay,
So
great.
I think we can, like, contact.
Great.
They can
Thank you so
contact you
much.
by LinkedIn. Yeah, yeah,
Thank you so much.
yeah.
Okay, so these are the 4 characteristics: information, story, goal, visual form. I'm not going to spend a lot of time on this because there are so many other interesting things I have to show you. But I want to point out 2 specific things. What happens when um, your visualization has information, goal, and visual form, but it does not have a story? So, for example, you have information, goal, and visual form, and it does not have a story. Well, when that happens, you see this intersection here, right? It becomes boring. Also, when you have a good story, good information, and visual form, but not a goal, then this whole point of creating and sharing visualization is useless, right? So, if you study this, it's pretty self explanatory. If you study this, then you will see that all 4 are very important ingredients of a visualization. Okay. So that means, based on whatever we have talked about so far, I think we should have had a different title for this presentation. So here, our initial title was that how decision trees can make good visualizations. But if I really think about it, I would prefer this title: how decision tree can help improve our story. Right? And that is exactly what I'm talking about. And visualization is just one way of communicating the story. So with that, let's start with a very familiar story. Okay, a story that we all know, that we all emotionally connect with. This is the last photo taken of the Titanic before it sank. So you see how emotional it is. Hundreds of people died um, in that disaster, and this is the last photo taken when it was whole, when it was not broken into two pieces. So this is a very emotional picture of Titanic, right? So I'll tell you a story about Titanic today. I'll start with data, and I will use decision tree to make my point, to tell my story. Okay, so let's go back to the picture. This is the last photo of the Titanic, and most probably, although this is the last photo and the most authentic photo of the Titanic, most probably this is our favorite photo of Titanic, right? I mean, whenever we think about Titanic, we think about this, right? Um, and I want to show you one more picture on a lighter note, and that maybe this is a picture that saddest love, where the sharks are watching Titanic and they're saying that I just love happy endings, right? Because what is sad for me might be happy for someone else. So just wanted to share that. But anyway, we need to focus. We don't need to divert. Okay. The reason I showed you all these pictures and I talked about Titanic is that eventually I'm going to refer to the Titanic competition in Kaggle. I'm not sure how many of you are familiar with the Titanic competition. It's one of the very basic and one of the most popular competitions, machine learning competitions in Kaggle. So what happens there is uh, there are there's a total list of Titanic passengers, and it is assumed that in the middle of the rescue, at some point of time, some people were saved, some people were not saved. And based on that information, we are trying to predict whether the remaining people, out of the remaining people, how many will be saved and how many will not be saved. So it's a pretty straightforward um, exercise to predict who will survive and who will not survive depending on their profiles, depending on their various characteristics. So if you go to Titanic, you will be able to, um, download the data and play this competition. It's a free competition, and it's a great place to learn. I mean, if you're new to machine learning, predictive analytics, new to decision tree random forest, XGBoost, new to data wrangling, or data imputation, feature selection, this is a great place to brush up your skills or learn more. So what I'm going to do today is I'm going to take only the training data from this Titanic competition, only the training data, not the testing data, because our objective is not to predict, but we'll take just the training data and we will try to create visualizations from it. And based on that, we'll see what stories we can tell about the rescue process, about the survival of the passengers. So I'm going to show you the data in a second, but let me walk you through the various columns, various data points we have. So so far I remember there are 891 rows in the data set. That means we have data on 891 passengers and the corresponding indicators of whether they were saved or not. So the survival is marked as 0 or 1. So 1 means they are saved, 0 means they are not saved. We have data about the P class or the class. As you know, there were three classes in Titanic: first, second, and third. And um, we have the information about who belong to which class, their sex, their gender, their age in years. The SP, basically, it is the number of siblings or number of spouses who are in the Titanic. That means how big my family is, how many siblings I have in the Titanic itself, or spouse. I'm not assuming. I'm assuming that it should not be plural here, but siblings or spouse, part or parent slash children. How many of my parents are are here in Titanic with me, and how many children are here with me? So these two are those columns. The ticket number of the passenger, the fare, how much money the passenger paid, and as you can imagine, the fare might be very related to the class. The cabin, in which cabin? Similarly, the cabins also might be very related to the class because it might be indicated whether it's a first class cabin, second class cabin, or third class cabin. And then the last one is the port of embarkation. There are three locations. Um, so their port of embarkation are also mentioned in the form of C, Q, or S. So this is the whole data. I believe there are around 14, uh, 10, maybe some more, maybe, and there are around 891 rows. So the data actually looks like this. You see the passenger ID, unique number, they are whether they are survived, they survived or not, which class they belong to, their names, their sex, their age, the sibling spouse, how many, parent children, how many, their ticket number, their fare, their cabin number, and their embarkation. And let me show you the actual data. I have the data open with me.
So
I
there
will.
is a disclaimer to the people over here. A small disclaimer is that those who are thinking that it's going to be the usual Titanic data prediction and stuff, it's not going to be that. Okay, so stay till the end to understand and discover what Abhimanyu Gupta has different thing on his plate. Yep.
Yeah, so I'm just using this particular data set. I'm not solving a machine learning problem. I'm not trying to actually play in the competition. The objective of this particular discussion is not to show you how to play in that competition, but rather I'm only taking the training data and I will visualize.
So this
Uh,
data will tell you what is the story behind the Titanic that you will not understand
yes,
with the naked eye.
exactly,
Yes.
exactly. So this is the data, and as you see, there are 891 rows, 891 people for whom we have the data. And what what my next step would be basically to study this and understand what might be going on. So let me start with some assumptions. Most probably, you already know that people in the higher classes were saved more. Most probably, you are already aware of the fact that females were saved more than males, right? So those are kind of very obvious, very straightforward insights. But when I talk about visualizations, I'm not referring to those straightforward, obvious kind of um, insights or stories. Rather, we'll go deeper, and then that is exactly where we will will use the decision tree to find out what else we can know from the same data. So let's see some visualizations, okay? And what I did was I did not create these visualizations. I just curated them from internet because they're available, and some of them are really obvious. So, for example, um, survived and dead. So it's basically sex versus survived. And from here, you clearly see that males died much more than females, and females were survived much more than males, right? So this is one of the very basic visualizations, and I'm going to talk today in a way that it's tool agnostic, because these visualizations can be created in any tool of your preference. It can be Tableau, it can be Power BI, it can be R or Python, and maybe even in Excel. So this is one of the visualizations I wanted to show you. It tells us something, but It's not something new because we kind of already know this. The second one is the passenger age distribution. So the browns survived and the blues did not survive. So when we look at this histogram, we see that we can safely say that the difference between survived and not survived is pretty uniform across the various age groups. There are some differences. For example, Brown's a little more here, here, but more or less, the age did not matter that much. It's a kind of a uniform, not uniform, but the two distributions are very similar to each other. So from here we can clearly say that um, that the age did not matter in the decision of whom to save and whom not to save. Obviously, there were some decisions made by the authority, by the captain, maybe, of Titanic. Obviously, there were some decisions that were made. And we are trying to find out how the decisions look like. So, for example, from here, maybe the decision was that the females, maybe the mothers, they need to be saved more. Uh, Age does not matter. The third one is the class. And that is kind of also very obvious to me that there are many dead people from class 3, whereas others are pretty uniform. There are much more dead people from class 3. So this combined with this, we can clearly say that the profile that were most affected was the males who belong to the third class. Right? So this way, what I'm showing you is a traditional process. This is not the theme of this talk, but I wanted to show you how we traditionally think when we explore, when we do the exploratory analysis with the data. And then I'll show you how a decision tree can help improve these visualizations. Similarly, family members, I'm not going to spend a lot of time here, but family members, you see, for dead people, for most of them, there were 0 family members. So, which means if you do not have your family with you, then you are more probable to die. If you have your family with you, if you are part of a bigger family, then most probably you will not die. At least your probability of dying is less. But as you see here, the 0, it means that the people alone in the ship died more. And once again, the passenger fare, it's also very obvious that more money you gave, more you survive, because everything here is brown, whereas the proportion of blue increases with the decrease in the fare. So one might say that these are some of the very obvious, very clear outcomes of your exploratory analysis, right? But are there more interesting stories? Can we dig deeper? Can we combine various variables that we usually do not do? And if we plan to combine the various variables, how we should do it? Should we just pick 2 variables randomly and plot them, or what should be our path? And that is, to be very honest, exactly where a decision tree comes into picture. So let's go to that. Will a decision tree help find those stories? Okay. But before that, let's quickly talk about what is a decision tree.
Yeah, but I will just uh, like stop you for a minute. So there are some
Sure.
fans of yours. They are telling that he's amazing. So yeah, I mean your explanation is amazing. So I also think so. So yeah, that's really good. Like I'm really fortunate to have Abhimanyu Gupta on the show, and if you're enjoying do like show your support by sharing to your friends and subscribing to the people. Okay, guys. So yeah, what is the decision tree, Abhimanyu
Yeah.
Gupta?
So well. Before that, don't speak too soon. Okay, I might disappoint you. So just wait until this talk is over,
Yeah.
and then you can make comments. Okay. Um, in sports, there is a saying that don't celebrate early, right? Um,
Yeah.
so so what's the decision tree? So I know most of you are already familiar with the decision tree, but for the sake of completeness, I just wanted to make sure that I talk about that. So this is a data set that decides whether the recess in a kindergarten school will be inside or outside, depending on the weather. So in the lunchtime, whether the teachers should let the kids play outside or inside, depending on the weather. So that is what this data set is about. So you see, if the outlook is sunny, temperature is hot, humidity is high, then the play outside is no. Whereas it's mild rain, um, play outside is yes. Um, Sunny, cool, normal, yes. The question is, can we identify the pattern? And there are various ways to identify those patterns. One of the non-parametric ways, and I'm pretty sure you're familiar with the term non-parametric. One of the non-parametric ways of doing that is basically to study the individual um, relationships. When the outlook is sunny, then the chance of yes is 40%. It's 2 out of 5. When the outlook is rainy, the chance of yes is 60%. When the windy is true, then it's a 50-50. If it is false, then how many? 6 out of 8. You do the math, but you get my point, right? When we study them individually, then we have a better picture. And then when we select what is the most significant, when we statistically select, usually they are, I mean, very loosely speaking, they are selected based on the p-values from their chi-square tests. And based on that, when we combine them, we try to form a tree. The tree kind of looks like this. So this is kind of a rule that we extracted from the data itself. It's not the other way around. It's not that you are a programmer and you are coding an if-else statement and then the data will behave accordingly, but it is the opposite of that. We are trying to create an if-else statement from the data itself. So this is the outcome, this is the output of the data set, and this is the rule that we came up with. And from the data, it's very evident that when the outlook is overcast, then we should always let the kids play outside. When it's raining, we'll check whether it is windy or not. If it's not windy, then they should play outside. If it's windy, then they should not. And similarly for the humidity, we have a similar rule. So on a very high level, this is a decision tree, and this decision tree actually helps us make a lot of decisions because that is how the data exhibits. The individual nodes are selected based on their significance in terms of their ability to influence our primary variable of interest, which is play outside or not. Right? So on a high level, this is decision tree. But seriously, how can we help? How can we use the decision tree to on Titanic dataset to extract better stories? So let me show this to you. This is the data as I showed you. And I'm going to use an application that I developed a few days back. And there are many other applications available that creates a decision tree. I prefer to use mine because I can customize things based on my own needs for teaching and research. So this is an open to all. Most probably, Srijit, you have the link to this, right?
Yeah. Yeah. Yeah.
So this is an open to all application. I created that using Shiny, and I'm going to grab this data and I'm going to try to create some decision trees and try to study. I'll not only create, but I will also try to interpret and extract stories as well. Okay, so let's go ahead I just grab this data, and my dependent variable, as you can imagine, is survived, because that is what we are interested in knowing. Um, it's it's a survived, which is the dependent variable. And then I'm going to try with various independent variables, and I'll see how the decision trees look like. So first, as you know from this slide, class, right? The class mattered in the survival decision. So let's see if it's true. So when I clicked on P class, it created a decision tree automatically. So it said when the class is 3,
Is it possible to zoom in a bit?
let's
Control A.
see.
Yeah. Yeah. Perfect. Perfect.
Okay.
Yeah.
Um, so you see when the class is 3 greater than equal to 3 means 3, because 3 is the last one, the last number. The chance of survival is only 24%, and 55% of the population belong to the class 3. So the chance for survival is 24% for those 55% people who belong to class 3. This is less than 3, that is either 1 or 2. So more than equal to 2, and less than 2. So I'm assuming this is 1 and this is 2. You can clearly see that the survival probability is 63% for those who belong to the first class, and the probability is 47% only who belong to the class 2. So you can clearly see the decrease, 63% to 47% to 24%. So which kind of is aligned with this kind of graph. Actually, it is giving us more information than the graph, if you ask me. And then I'm going to click on sex individually, just sex. I removed the P class. If this is my independent variable, then it's very clear that if the sex is female, then the survival chance is 74%. And if it is a male, then the survival chance is only 19%, which also kind of in alignment with this in some sense, right? So we can clearly see that the stories can be extracted very easily from the decision tree if we create the right trees and if we can interpret them rightly. And now I'm adding both of them. So when I'm adding both of them, then both sex and the P class come into picture, because looks like there are some differences with respect to the intersection of sex and P class as well. So for example, the way to interpret that is if it's a female and they belong to classes 1 or 2, then their chances for survival were 95%. If the female belonged to class 3 or the third class, then it was only 50% chance. However, for the males, if it is 2 or 3, then the survival chance was 14%. And if it is 1, then it's 37%. You can clearly see the difference, the discrimination in the decision making process for the survival, right? But so far, whatever we have seen here is kind of obvious, and we have already seen those things in our graphs. So in order to dig deeper, in order to find more, I'm going to keep adding the independent variables, and then I'm going to keep interpreting, right? So let's say I added age, sibling, spouse, and parent, children. Now let's study this tree a little. We can clearly see that if the sex is male, then this person, males have only 19% chance of survival and the females have 74% chance. Similarly, if we have already seen the P class and everything. right? But suddenly this sibling spouse is appearing. And that is where my interest would be. So just let's take a moment and try to explain this branch and this branch and try to see whether an interesting story is coming out of it or not. Okay. So here's my first shot at this. If the sex is male and if the age is less than 6.5, that means male kids, age less than 6.5, sex male. So male kids had overall 67% chance of survival. However, if the kid has less siblings, I'm eliminating spouse here because a kid cannot have spouse. So I'm focusing on the siblings. So watch it carefully. If the kid has less than 3 siblings, that means if the kid has less brothers or sisters, then the probability of survival is 100%. However, if the kid had more brothers and sisters, then the chance of survival was only 11%, 1/9. You can clearly see what is going on here, and it is so emotional and it's so disturbing. I'll explain why. If I was a parent and if I had more children, most probably I was given a choice to save only 3 of them or maybe 2 of them. If I had less children, then most probably all of my children were saved. But if I had more kids, then it was very clear that not all were saved. See, this is where this whole story is coming from. And we have a very similar story for the females as well. However, they did not depend on the age, rather they depended on the class, the third class. If the females were in the third class and they had less family members, then their survival chance were 55%. If they had more family members, their survival chance were 17%. So if I only look at these two branches, a very strong, very emotional, and very sad story is coming up that the male kids were saved based on how many brothers and sisters they had. I find it really inhuman. And I could not find it, this story. Shrijit, we stopped sharing, I believe. Did we stop sharing? Oh, okay. Sorry. So as I was mentioning that it's a very disturbing story. And it was identified only using a decision tree because I believe no matter how many visualizations you create, most probably you won't be able to reach to that point where it involves 3 different variables: sex, age, and sibling spouse, and the survival, of course, 4 variables. So that is exactly where a decision tree really helps understand the story. And when we understand the story more, we create better visualizations, and that's how, based on that, we make better decisions. So I just wanted to show this particular example to you that most probably, I don't know what happened there in Titanic. I was not there, fortunately, but the data clearly shows that it had to do with the number of family members you had when it was decided whether you will be saved or not. And that was kind of, I don't know whether it is fair or not, I don't know whether it's ethical or not, but that is something that happened. And when I found this out using a very simple decision tree like this, I mean, I was a little disturbed because I did not expect this from the data. So um, I try to demonstrate to you how a decision tree can really help understand good stories. So you see, if I go back to that slide once more, you see there's information, there is a very interesting story, there is a goal, and the goal might be to understand the strategy. Maybe if you are in a business or if you are in a situation where you are trying to make decisions, most probably these patterns will help you make better decisions, right? And there is a visual form too. So um, if I fast forward, I actually created the decision tree and the visualization out of it. So this is the visualization. You see, it's the same exact visualization that I showed you. I pasted here for easy reference. You see the sibling spouse and everything here. But the last piece of the puzzle is how we can convert this to a visualization. And that is exactly where I thought this visualization, for example, might be really useful. That for males, the survived, the the proportion or the trend of survival really decreases. Whereas for females, these are parallel. And I try to create this using age, sibling spouse, gender, and the survival. So this can be a good visualization, but most importantly, this can be a good story. And this is another way of visualizing this. Basically a 3D scatter plot that I created. 0 is dark, 1 is light. So you see who has survived and who are not. But for the males, the most disturbing is this area. For males, and the vertical axis is sibling spouse. For males, when we go up this way, then we see the survival indicator is changing from yellow to black. And very precisely, it's after 2 or 3, it is changing to black. If I traverse in this direction, it's a very similar story here as well. That means everything else is the same. I'm still a female, and I my age is also the same, but I have bigger and bigger family. So when I'm having bigger and bigger family, after some point of time, I will not be survived. I will not survive. So this direction and this direction, it's clearly showing this. And as I mentioned before, it's not impossible, but it's very difficult to find this only using visualizations and exploratory diagrams. So that's all I had for today, just to show you, just to demonstrate to you how decision tree can really help in understanding the story and create visualizations accordingly so that we can make better decisions. So with that, I'll stop and I'll try to answer your questions that you might have for me.
So it was like total, like I never used this actually personally to understand, and it was a total an eye opener for me, like how we can, like I previously used to like understand through the data how to use visualization. So this algorithm is like will help people to understand, like, okay. So one of the students is asking, how can you explain the code to draw one of these decision trees in Python? Ashish is asking.
Well, I can share that with you. I did that in R. I did not use Python, but there are many code snippets available in the internet. Just send me an email, and I will send you whatever I have on the. And it's very straightforward. I mean, it's not a difficult thing to do. So yeah, contact me, send me an email, and I will.
Yeah, so one thing, like, will I share your like app link to this to the people?
Sure. Well,
Okay.
you can
There
always
was
share
like
that. I
there
mean, we
was
can.
you told me like there are some bandwidth issues. I mean, a lot of people
That's
if go
fine.
to your
That's okay.
okay,
So
fine.
there are some bandwidth issues, but there are no access issues. So anyone can access. They might experience some slowness, but they can still access. But the other thing is, no one will be able to see the code. So it is just an application. The application that I used in this demonstration, anyone can use it. But if you are interested in codes, you won't get that from the application. So that's where you contact.
Perfect. Yeah, so you can contact sir on LinkedIn for further. It's best to contact him. Go to his LinkedIn profile and get his email ID. So can you share your email? I will write it once here to the people.
I can write it here.
Yeah, perfect.
Am I allowed to write? It's not letting me. Oh yeah, yeah.
Yeah, yeah, you are allowed to write. Yeah. Yeah, so Sarath Jain is asking when to use Kaggle after studying ML or before studying ML.
uh, After studying ML. Kaggle is a platform where you can apply various machine learning techniques and you can refine, you can learn more by doing things on your own. So I would recommend that you should have some background and some working experience of machine learning, whether in R or in Python, before you go to Kaggle. But once you have that, then you will be able to uh, do experiments on your own and refine and advance your skills from there.
So any other questions, guys? Like I'm totally blown away, so I have no questions in my mind as of now. Maybe I will contact you in link on LinkedIn after this session.
Sure, sure.
Any questions, guys? So you are telling me that you have yeah, like it's better to use decision tree to understand which are the interesting relationships and hence take action on. Okay, data visualization. I have a question here. So, sir, can you explain why decision tree tends to overfit? Okay. Will the app work on parametric data as well? What do you mean by parametric data?
Okay, let's go one by one. Let's
Yeah.
start with Sarath's question.
Yeah.
Um, or it was Divityas.
Sarath is
Um,
asking. Let's start with Sarath's question.
I'm a fresher. Where we can learn Tableau, any stories. Well, there are many YouTube videos available for Tableau. You can watch them. There is a free version of Tableau called Tableau Public. You can download it, you can use it. There is no license needed for that, although most probably not all features will be available to you, but you can still go ahead and learn it. And I learned Tableau this way. I mean, I watched many YouTube videos, um, and Tableau is very user friendly. So um, you can go ahead and watch the videos and learn by yourself. There was another question.
Can you
What was the
explain why
question
decision
about
tree?
overfit? Okay.
Yeah.
Can you explain why decision leads to overfit? Right, right. So decision tree, the problem with decision tree is one of the foundation stones. There are many other machine learning algorithms that were built on top of decision tree, where the primary objective of building those advanced algorithms on top of decision tree was that to use the strengths of the decision tree, but to overcome the drawbacks of decision tree. Some of the examples of those advanced um, machine learning algorithms that are based out of decision tree are random forest, um, XGBoost, gradient boosting, adaptive boosting, and there are various other methods that are based out of that. So decision tree is not a very refined machine learning algorithm, and that's why it's very important if you want to use it. You want to be really particular and careful about the data quality. Whereas the advanced techniques sometimes take care of those, but decision tree is very naive, and you need to feed the right data in the decision tree. It's very similar to um, when you buy potatoes, you have to peel them. Yeah, in order to make chips, you have to peel them, you have to cut them, then you can fry it, right? So decision tree is like that. There are some preparation steps. On the other hand, you can go to some departmental store and buy ready to fry chips as well. So you just buy it, open the pack, and you start frying it. So decision tree is just like my first example, and those advanced techniques are um, examples of the second. Right? So it's once again it's not very refined. So we have to be really careful. I mean, when I fit decision tree, I always check for multi-collinearity. I always check for the dependencies. I usually create correlation matrix, heat maps. Sometimes I do feature selection if you're familiar with those before I fit a decision tree. So it is, you have to be really careful. You have to handle it carefully. That is what it is for decision tree. Whereas for random forest, for example, you don't have to be that careful because it is an advanced technique. Okay, Sujit, what are the other questions we
Yeah.
have here?
So other questions are: I'm a fresher to visualization. Learn Tableau. Where to learn Tableau? He has already answered. Okay.
Yes.
Will the app work on parametric data as well? So I'm a bit confused on parametric data. What
Yes,
this means.
I'm not sure whether what is the meaning of parametric data. There is no parametric data. There is only parametric models, parametric and non-parametric models. So there are um, models like linear regression, logistic regression, machine learning algorithms. Those are all parametric. They demand linearity of the data. They demand normality of the data before they are fit. And we actually, the model is defined in terms of the various parameters of the model. Whereas the non-parametric models are like decision tree, for example, and any other techniques that are based out of decision tree. So but if I understand your question correctly, I mean, yes, I mean, decision tree can be applied on all data. So you don't have to, it's not like you can apply decision tree only one particular form of data and not on others. It can be applied. If you are careful, if you do the right preparations, then you will get a better result, get a good result out.
Perfect. Okay. So how to start machine learning with unaware of programming basics? So I think Abhimanyu Gupta is the best person. So
So the way, see, I teach in a business school here, and I cannot expect that the business school students are technical. Actually, most of them are non-technical. They have never done coding. They have never touched R or Python or JavaScript or C++, because sometimes, most of the time, they come from non-technical backgrounds like geography, like political science, like sociology. So the way I teach is I have created um, some code generation tools, and based on that, I teach them. If you want to really learn machine learning without programming basics, then there are some tools available nowadays, like Rapid Miner, or I believe Data Robot is one of them as well. So there are some licensing fees, but the actual process is really user friendly. So you should be able to do that on your own.
perfect. Okay. So the next question is: can we learn data visualization without learning ML or DL? I mean, this data science he means.
Of course,
Ashok Sharma.
of course. Can you see my slide, the book?
Just give me a minute. Yeah, I
Okay,
think they can see it now.
right. So try to buy this book. This book has nothing to do with machine learning. It's all about data visualization and storytelling. So if you want to learn good visualization without going into the details of machine learning or data science or anything in advance, um, just just buy this book. Most probably, there might be copies available in the internet as well in the PDF format. I don't know. There are good videos in YouTube about this book as well. So I would recommend this book for learning only data visualization if you are interested.
Perfect. Okay, so they are interested in knowing about your journey. That I will just share the question. Sir, how did you? What do you? How do you land at DT? I don't know what DT means. I think he means data science, and what influence uh, your analysis, Amar Raju.
I'm just trying to find the question so that I can
So I am
answer it.
actually on the screen. Can you see the screen?
Yes. Oh, okay. How did you land at DT? Okay. What influenced your analysis? Okay. Uh, oh, decision tree, I believe.
Yeah, region tree. Okay, yeah.
Yeah. So that was. So this is where, and I was talking to Srijit, I believe yesterday, that is exactly what my research interest is. That I try to combine completely unrelated topics to solve problems. I try to combine share prices with sentiment analysis, share prices with game theory. Srijit is smiling, so because he knows it. I try to combine visualization with machine learning. You can say that that is my area of interest in terms of my research. So I was trying those things, and then I found that this can be a good method.
Yep. So yeah, you understood. Okay, so Priyesh, Raj is asking another question. You can see on the screen again.
Which should I learn, Power BI or Tableau? Um, if you really want to learn data science or data analytics, you have to learn it in a tool agnostic way, because the tools will come and go. Today it is Power BI, tomorrow it can be Power CI. I'm just making it up, sorry. But um, you have to learn the theory, you have to learn the concepts. See, uh, Srijit, I was hearing you talking about um, Start with Why, Simon Sinek's work in one of your previous um,
He's
talks,
one of my
right?
favorite authors. Yeah.
Is he's mine too. So I'll refer to that golden circle. Why, what, and how, right? You have to understand why you are doing this, why you are using decision tree, and why we are solving this problem, and then what problem you are solving, and what is the benefit. And then the last, the superficial part is the how to. And from my experience, I can tell you that will keep changing. Yesterday it was Excel, today it is Tableau and Power BI, tomorrow it can be something else. But if you have a strong foundation in terms of the concepts, then it won't take a lot of time for you to learn a new tool. So to answer this question, it does not matter. You have to choose one, and you have to know it very well. Because
Okay.
if you learn one and know it very well, then you won't take a lot of time to learn the other. If you have the foundation, if you know the concepts.
Okay. There's a question by Sharad Jain and also Shikhar Yadav. It's the same format that they're quite confused. I think like which tool to use for their analysis, and I think you're the perfect person to help them out now.
Well, I have the same answer here, right? I mean, I get this question all the time: Python or R, Power BI or Tableau, and I have the exact same answer. Pick one and be a master of it.
So by picking
Because
one, you mean like non-coding platform or coding platform?
one non-coding platform and one coding platform. If you're interested in coding, if you're not interested in coding, then don't worry about it. Don't worry about it. But just if there are competitors like Power BI versus Tableau and Python versus R and things like that, always pick one. There are very don't even read which one is better. Those blogs are useless because they are both very good. It's very similar to which vaccine is better. It's a meaningless question. Getting vaccinated is important, right? So it's a very similar situation. Pick one, they are very similar to each other. In some aspects, one is better than the other. In the other aspects, the other one is better than the first one. So don't worry about that because you're just starting, so it does not really matter to you. Pick one, don't toggle, go deep, learn it as detailed as possible. If you do this, then the other one will be automatically very easy for you.
Okay, perfect. Yeah, so Mahima Jain is asking one question is that um, so we can say the decision tree is one of the best way to visualize our data than using any particular chart or in case of any large number of features. Yeah, not the best way. I mean, one of the good
Okay.
models. Yeah.
Okay. Let me start with disappointing you, Mahima. Data science is not a science; it's an art. If you think of any art form like singing or painting, there is no one right way. You might, I mean, typically what you will do is you will follow your guru's paths, but you will also understand the fact that that is not the only path. Um, so, what I would say is decision tree is definitely one of the ways. I work very well with this technique, but I cannot claim in no way I can claim that that is the best one or one of the best one. It's just something that I picked up. I looked at it in full detail, and I was able to use it to so that it can serve my purpose. So for you, you have to find your own path. You have to find your own style. Um, but you can definitely start with the approach that I showed you. But there is no way I can claim that that is the best or one of the best ways. It just works for me.
Perfect. So yeah, Mahima, I hope you got your answer. And then I come to Saraj Jan's question. Um, he asks about he wants to become a data analyst and he wants to master. Yes. He knows advanced Excel. After that, what is the roadmap for him? He's very confused. It seems.
Okay, so assuming that you are only familiar with Excel and you are not familiar with a lot of mathematics, statistics, kind of things, my recommendation would be to start with statistics. If you really want to be a good data analyst, you need to know statistics. Well, statistics is not data analytics, but statistics is the foundation for analytics. So if you know statistics in detail, then you will be able to be much more equipped when it comes to data analytics for you. So I would start with statistics like normal distribution, testing of hypothesis, chi-square distributions, t-tests.
What do you think
And
is a good book for this? Basic. I will tell you what I prefer to for my students. I tell my students like not my students but who ask me that Friedman Pisani Statistics by Friedman Pisani. It's a very basic book, but you have another choice. Like, do you suggest your business people like students?
I will I will I will um, that brings back so many memories. When I joined Presidency College for BSc, our department chair was Professor Goon, Atindra Mohan Goon, Professor Atindra Mohan Goon. So it's a
Gupta
Goon.
Gupta ka kaun?
Yes, yes, yes. So he was the head of the department, and we also had by the time Gupta and Dashgupta, Professor Gupta and Professor Dashgupta retired, but time to time they used to come back and give us occasional lectures as visiting professors. I really love their approach, the Gun Gupta Dashgupta, basic statistics, and there are few other books after that. So and they're pretty easily available. I really like those books pretty much. Um, so Professor Gun did not he did not like me as a student, but that's a different story. But I really like his books, so I would I would recommend Gun Gupta Dashgupta as a starting point.
Perfect. So Gun Gupta Dashgupta. Yeah, that's a very unique name. I That's really good.
Yeah.
Yeah, so unique suggestion actually. Okay, so Ashwin is asking the following question that it's necessary to learn the mathematical concepts behind decision tree like entropy, information gain for storytelling purposes.
Once again, I'll refer back to the golden circle of Simon Sinek. You can go by knowing the how to only this far. For visualization storytelling, most probably not. Most probably you don't need to know the mathematical concepts that much because it's more art, it's more story. I believe for storytelling, you will learn more by watching good movies than learning mathematics. How the suspense is built, how we reach the climax, how to unfold things slowly to reach to the climax, how to end your story. I believe if you keep watching films or movies of good directors, you'll learn much more than learning mathematics. However, that will take you only this far. After some point of time, if you want to go further, um, then um, then you need to know the mathematical concepts and statistical concepts. If you are so here is the analogy. Right now you're saying that I'm interested in high jump. So go ahead and high jump. You will do just fine. But later on, if you want to have the option to switch to pole vault, then you need to understand the pole. And that pole is your mathematics and statistics.
Yeah, that's a lovely way of explaining. Yeah. So Shikhar is asking, what is the roadmap for data analyst?
There is no roadmap. What is the roadmap for being a president? There is no roadmap. You have to keep learning, you have to keep applying, you have to keep thinking, and you have to traverse your own path. You don't have to follow anyone. If I give you a map, then that will not make you a good data analyst. You have to find your own way.
Perfect. And last question for today is he has completed BSc in statistics and operation research. How good or bad it will be pursue MSc data science if I don't know coding but love statistics? Yeah, okay. You're I think you're going there to learn it, so
Okay. So I will give you an example of the time when I was growing up. I passed my higher secondary in 1995. And as you all know, Windows 95 came on that year, right? So that point of time, we did not use computers for data analytics or for learning statistics. That point of time, we used to, use square papers and we used to draw the normal curve by hand and pencils. That's how I learned. Okay. Um, then the computer came and there were debates about whether computers are actually going to be useful or not. And in no time we found out, I think everyone found out that computer is something that we all need to know no matter what we do. Whether we do reporting, whether we are historians, whether we are data analysts, um, we all need computers. So at some point of time, we realized very quickly that everyone needs to be computer literate. There is no way out. Now you cannot think of a job. Now you cannot think of a white collar job that does not use a computer, right? My understanding is it is going to be the same thing for coding. Right now, we are debating, do we need to learn coding? Do we not need to learn coding? Can we survive without coding? But in next 10, 15, 20 years, 30 years, I don't know how long, but in after a few years, we'll again realize the thing that we cannot survive without the basic coding. Simple coding, Excel macros, a few lines of R, few lines of Python. So temporarily, I understand that your background is not coding, but if you really want to be a good data analyst, if you want to spend your life doing that, if you really want to spend your life doing that for the rest of your life, then there is no way out. There is no escape. You have to learn coding because the whole world is going towards that direction. I don't know if that answered your question or not.
Perfect. Yeah. So that's like settled now for you guys. Now go ahead and learn some coding. But if you want to spend the entire lifetime with data science, okay. Otherwise, no.
Correct.
Otherwise, like, yeah. Otherwise, it's up to you. Like, if you want to change jobs, go to some other departments, up to you. But if you want to spend
Correct.
your life with data for the rest of your life, then I think it's needed. That's so close
Exactly.
to the hard answer. Perfect. Yep. So, any other questions, guys? We have answered a
I
lot
think
of questions. We have answered
I
a lot
think
of technical questions. I mean, you have received these questions a lot of times. So yeah.
yeah.
So okay. So there are no other questions. Thank you guys for your nice participation and for your time and asking beautiful questions. Thank you, Abhimanyu, Da, and Guptas, both to. Yeah. Okay. There's another question. How did you develop the decision tree? You need to learn some coding.
Yeah.
Uh,
I I created this application and that helped me develop that.
yeah. You can also. I think there's a recent book. There's a recent book published on our Shiny app by O'Reilly Publication. You can actually go there. Like, isn't like I just saw a LinkedIn post. I think you can go there and
Right.
um, see that book. Thank you, all of you. Thank you, Abhimanyu, for coming
Thank
to this
you.
and give a
Thank you
beautiful
so
session.
much for attending this session. It was wonderful meeting you all, and feel free to con- contact
Yeah,
me
so
if
I
you
already shared his LinkedIn profile. I will again share his LinkedIn profile. Just give me a minute.
sure. Please do. Please do.
Yeah. So I will share
And
it in. Yeah, it's already in the description, guys. You can check it out in the description once. Uh, and I will also share in the comments. Okay. Now. Okay. So just give me a minute. Yep. So when is the next session? The next session is on. I will tell you. I will announce in the LinkedIn, and I will see what are the next sessions. Can be with Abhimanyu. It can be with other people. So do stay in touch with us. We have a lot of interesting plans coming up, guys. One of them is we are planning to organize and collaborate with Abhimanyu Gupta and other professors and instructors all over the world for some research internships, and let's see where it goes. And we have already selected three, not selected like it like we are. I am actually selecting, preferring the Chinta statistics students now, and we are collaborating. And we have selected three people out here, but they're in on the still selection mode. And let's see where it goes. And I hope this research mindset is a very important aspect of the future, and it's really slowly coming the mainstream nowadays. And all the best, guys. And if some doubts regarding this, do let me know, or Abhimanyu know. He will actually tell me to ask to connect to me, and then we can go ahead with some interesting ideas. Okay. Thank you guys for your attention and your participation. Thank you, Abhimanyu, for coming to for
thank you.
helping uh, like helping to give a different view of apart from what public gives about data science, and how visualization and the story is really important to the whole thing. And yep, so I remember two statements and quotes by Abhimanyu while talking to him during these days. So there's a main like this debate between what is applied and what is theoretical. So Abhimanyu, can you tell it once again to your audience?
I don't remember what I said, but maybe if you remember, you share this.
Okay, so I asked you, and he told that applied is like applied people try to be useful and theoretical people try to be right. Okay, that's the main
Right,
difference.
right.
So
Now
it
I
depends
remember.
what you really.
Yes.
Yeah. And another thing was that I really struck inside my heart is that he told that data visualization is also like a model. Okay, it's not different from a different, like it's actually a different model. Okay, both are trying to tell the same thing. One is in terms of numbers, one is in terms of visualization, one is in terms of prediction and stuff, and one in terms of visualization. So both are actually
Yeah.
the same thing.
Right.
So
A machine learning model is a model understood by machines, and a visualization is a model understood by humans.
yeah, perfect. That's the quote. Yeah, perfect, perfect. So yeah, with these two beautiful quotes and understanding, and you can clearly understand his love for data. And if you want to imbibe that energy inside you, so do have a talk with him over LinkedIn. I have already shared his, I think shared his link, right?
I
I've
I
just
I, I already received 25 connection requests in the last
lovely.
one
That's very
hour.
good. That's very good. That's
Thank you
very good.
so much. It's
So
very sweet of you. I'll respond to them.
yeah, so there are a lot of thank you so much, guys. So yeah, thank you, guys, and let's bid you a good night to the IST Indian people, and let's bid you good evening, good afternoon, good morning to all of you who are there, and thanks for your support, guys. Bye
Have
bye.
a good night. Have a good night, everyone.
Yeah, bye bye, bye bye. Thank you.